focusing on the behavior of current in inductive, resistive, and capacitive loads. First on our list is the resistive load. Think about a simple circuit with a resistor. In this scenario, the current and voltage rise and fall simultaneously. This synchronous behavior is due to the absence of any phase difference. The resistive load, which can be anything like a light bulb or an electric heater, follows Ohm's law. The current flowing through a resistor is directly proportional to the voltage across it. So if we double the voltage, the current also doubles. Moving on, let's explore the inductive load. In circuits with inductive loads, such as motors or transformers, the situation is a bit more complex. Here, the current lags behind the voltage, creating a phase difference. This happens because an inductor resists changes in current due to the magnetic field it generates. So, when the voltage peaks, the current doesn't reach its peak immediately. Instead, it takes some time, causing the current to lag behind the voltage. Last but not least, we have the capacitive load. Capacitors are common in electronics like radios or power supply filters. In a capacitive load, the current actually leads the voltage. This might sound strange, but it's because a capacitor stores energy in an electric field. When the voltage begins to rise, the capacitor starts to charge, causing a current to flow. But once the capacitor is fully charged, the current stops, even if the voltage is still high. Hence, the current reaches its peak before the voltage does, indicating that the current leads in a capacitive load. So, to sum up, the behavior of current is distinct in resistive, inductive, and capacitive loads. In a resistive load, the current and voltage rise and fall together with no phase difference. In an inductive load, the current lags behind the voltage due to the magnetic field generated by the inductor. And in a capacitive load, the current leads the voltage as the capacitor charges and discharges. Understanding these behaviors is crucial in electrical engineering, as it helps in designing and operating electrical systems more efficiently.